everyone, welcome back. Good afternoon, Abhinandan, Aisha, Garv, Kirtana, Kimaya, Mihir, Samsung. Samsung, I would like to know your name. Shravika, Sneha, Devendra. Yes, a very good afternoon to all of you. And 8511, also a very good afternoon to all of you. Yes. So those who have attended my earlier sessions on permutations and combinations. So first time when, okay, let's see. Yes, good afternoon. A very, very good afternoon to all of you. So when first time I talked about permutation and combination, I think it was Navratri. And the second time I was conducting the lectures, Rose were going on. And unfortunately or fortunately, like more of unfortunately, like I took the example of food. Permutation and combination, I feel we can explain it with food easily for you to understand. And then the students were saying, "Ma'am, हमारे रोजे हैं, हमारे उपवास हैं, ये वाला example मत लीजिए." So I have changed the examples also depending on the time. But like now, I think nobody has any um, fasting to be done. So we will take the examples of the food also. Okay. The second thing I would like to tell you is that just a while ago, Rajkumar Adukia sir, who is handling the BOS, he is a CCM. He gave us a message that make the students enjoy mathematics, okay, and taking his lead. And I'll try my best to do that and make sure that you enjoy the maths. So, taking that forward, I would like to let you know is that usually what happens is when we learn something in accounts, we know the method. We don't go wrong, We only go wrong in the arithmetical thing. Huh? अरे plus करना था 20,000 मैंने 2,000 कर दिया. That type of errors. But in maths, what happens is every example is different. Okay. So some things will follow a particular rule, like in especially in permutation combination, you will have a formula for permutation, you will have a formula for combination. But for this chapter, especially, you need to read the question first to be able to come at a deduction. Okay. So what the plan is that I will make mistakes. Okay. It's okay to make a mistake right now than to make it in the exam. So what you will do is you will practice these sums over and over again. Okay. So that the more you practice, the more you start understanding the wording of the question. Hmm? Okay. This part, yes, मोहित, ये वाली बात मैं आपको हिंदी में भी बताती हूँ, लेकिन जो टीचिंग है वो इंग्लिश में रहेगी क्योंकि वो इतनी हिंदी मुझे आती नहीं है परमुटेशन कॉम्बिनेशन सिखाने वाली। लेकिन मैं आपको बताना चाहती हूँ कि एक परमुटेशन का फॉर्मूला है, कॉम्बिनेशन का फॉर्मूला है। ये फॉर्मूले हैं, ये आपके बेस हैं, ठीक है, ये आपको आनी ही चाहिए। आप सब मोस्टली सब बच्चों को अब तक आ ही जा रहे हैं जो जून अटेम्प्ट है या इवन सितंबर अटेम्प्ट वाले जो सीबीएसई आईसीएसई के उनको आता है। लेकिन उसके बाद भी ना ऐसा होता है कि आप सम सॉल्व करते हो, आपसे गलती हो जाती है। लेकिन ये सही वक्त है आपको गलती करने का, यहाँ कर लीजिए, यहाँ आप रेक्टिफाई कर सकते हैं, आप उसको चेंज कर सकते हैं, आप उसको दुरुस्त कर सकते हैं। एग्जाम तक आप मत रुकिए, अरे ये वाले में मेरे से बहुत गलती होती है इसलिए हम वो चैप्टर साइडलाइन करते हैं। ऐसा नहीं करना परम्यूटेशन कॉम्बिनेशन को, क्योंकि इसके ऊपर ही बेस्ड आपका प्रोबेबिलिटी का है। हम्म। तो ये आपको नहीं करना है। और गलती होती है, मेरे से भी होगी, आप देखोगे अभी सॉल्व करते समय, अरे ये ले लिया, अरे फैक्टोरियल गलत हो गया। ठीक है, इट्स ओके। जितना आप अभी करोगे वो आपको अंदाजा आ जाएगा, अरे मैं इस चक्कर में पड़ जाता हूँ और ये मुझसे गलत होता है। ठीक है। सो व्हाट आई एम ट्राइंग टू टेल यू इज दैट mathematics or the overall quantitative aptitude You may know everything, you have done everything, but there will always be a surprise in the exam. So don't get flustered. डरने की बात नहीं है. आपको अपने आप खुद पे कॉन्फिडेंस चाहिए और आप कीजिए. So yes, Mohit, that's okay. Any question, anytime I'm explaining something, you want to understand it, then you let me know, okay? But most of the things, what I have done today is trying to take example from the study material and trying to explain the logic. What happens sometimes is we read through the examples, we don't solve it, we read through the examples, and then we have not understood it well, and that is why we are not able to solve the exercises. So let us see, let me take you through the concepts, and then we'll try to understand what these questions are. Okay. So anybody can put it in the chat box. What is the difference between permutation and combination? Anybody? So you could start doing that. Okay. See, what is it that is something I know, but when I want to try to write it down, it becomes difficult. That is okay. So long as you remember what the difference is, and there is no need to remember it in a rigid way. Now let us talk about factorial. Factorial, you have fundamental principles. What are the two fundamental principles? Multiplication rule, addition rule. Don't worry, I'm going to take it. Yes, somebody's answered. Let me see. Excellent, Aisha. Combination order is not important. Now, Parul, is in combination order is important or permutation order is important? Yes, let me see you all. Yes, Aisha has answered very well. Yes. Permutation. Aisha is saying in permutation order is important. Very good. Okay. Then we are first going to talk about the multiplication rule and addition rule. Read through what is given in the textbook also, but I'm going to explain also. Then permutation and combination. We are going to try to understand how we are going to go about it. In permutation, you have properties, circular, and permutation with restriction. See, what I would suggest to you is that you should read this. This is important theory. This is important theory. Okay. You may even get questions where they are just asking you the formula. Let's increase the thickness a bit. Okay. And then you have permutation and combination also properties. So some of them are the equation types of properties, but other also you can see. So what we will do, this is for your understanding. Okay. This is more for your understanding. Okay. You must know this to be able to apply it to permutation and combination. Once you know what the multiplication rule is and the addition rule is, in word problems, you have to put it for permutation and combination. Okay. Yes, somebody said something. Yes, Mohit. Yes, very good, Mohit. Very good. Good answer. Okay. Now, what are we learning? Arranging and grouping. Okay. Arranging, you arrange something in a particular order, and grouping is you form a group. Okay. We will learn problems of arranging and grouping of certain things, taking particular number of things at a time. It should be noted that AB and BA are two different arrangements. Okay. So somebody like first, second, third. Okay, so A, B, C, first, second, third. Is C, B, A same? No, because A has come first. So can I say C has come first? No, I can't do that. Okay, so there is a restriction on how I write it. So I must write it in a particular way when I'm talking of arrangement. But if the same thing I'm talking as a group, I say A, B, C are three friends. Will it make a difference if I say BSc, BCA, CAB? No, they are a group of friends. Okay. Like if three of us are going for a movie, so it will not matter if I'm sitting on the 11th chair or the 12th chair or the 13th chair. Okay. It will not make a difference. But same thing when it is like if you have come first, second, third, then it will make a difference. So in case of arrangement, the sequence of order or order of things is taken into account. Okay, is taken into account. So this is very important. So now let us talk about differences. So right, as Aisha has already told us, let me talk in terms of an example of food. Okay, so suppose you go to a pizza shop and there you say one pizza is paneer and mushroom pizza and the other is mushroom and paneer pizza. And if you say to your friend, see, they are two different, isn't she going to laugh at you? She'll say, अरे पनीर मशरूम है या मशरूम पनीर है, बात तो एक ही है ना, एक ही तरह का पिज्जा है. So paneer and mushroom pizza and mushroom and paneer pizza are one and the same. When the order does not matter, so paneer and mushroom is only counted as once. Okay, if I say paneer and mushroom and paneer, they are not going to make a difference. In the menu card, you will see that as one only in the menu card. Okay, you will not see paneer and mushroom pizza 500 rupees, mushroom and paneer pizza 500. They will not do it that way. They just write it only once. Okay, so now choosing a book. Suppose you want to take some books for a trip. You're going out on vacation. If you want to pick three books, sorry about that. So if you want to pick three books to pack from a set of 8 books, what you can do is you will use combination. Okay, so you when you're choosing the books, it is a combination. Similarly, Dream 11, some of you must be playing that, family members are playing that. Then, if there are 30 people are there and you have to choose a team of 11, you will obviously choose some batsmen, some bowlers, some all-rounders, one wicket keeper, and all that. But the overall picture is that out of 30, you're choosing 11. So that is a combination problem. Okay. But these all three examples like pizza, then taking books and forming a team of players. These are all the examples of combination where I'm choosing. Okay. Now, what about passwords? Okay. You have your Gmail password, you have your phone password, your parents must be having their internet banking passwords. Is it going to be okay if I interchange the numbers? No. The order is important. Okay. If I have, say, a password ICAI hashtag 2024, can I write IC hashtag 2024? It will be a different password and I will not be able to log in. So securing password, it is a combination. As you all know, passwords usually on the internet, etc., are combination of alphabets. Then in alphabets also there is a combination of uppercase, lowercase. Uppercase, lowercase means capital letter or small letters. Okay. Then numbers or special characters. स्पेशल कैरेक्टर्स माने क्या होते हैं, जो हमारा परसेंटेज स्टार साइन है, हैशटैग साइन है, उनको स्पेशल कैरेक्टर्स बोलते हैं. सो व्हेन दैट इज देयर, यू विल से दैट दीज आर important. So the order is important. So this is an example of permutation. Same thing, race finish, which I already told. Okay, we are explaining with an example. In a race, if you have 5 runners, okay, if there are 5 runners, positions are 1, 2, and 3. This is the first person who is going to come first, second, and third. How many people can come first? All 5 of them have equal chance. Okay, when they are starting, all 5 of them have equal chance. Then one person will come first. So the person who has come first, can he come second? No. So that place is already booked. So suppose I have A, B, C, D, and E. So if C has come first, so he's already out of the picture. He's already come first. How many people can come second? 1, 2, 3, 4. So 4 people can come second. Then how many can come third? Then I have third. Okay. So this is for the podium. Okay. This is for the podium. But overall, there will be a 4th place and there will be a 5th place. Okay. So suppose B is coming second, E is coming third. Then who will come fourth? Either A or D. So suppose I say A has come and then D has come. So for 4th place, there are 2 people available, and for 5th place, 1 person is available. So this is known as, okay, this 5 into 4 into 3 into 2 into 1 is written as 5, and the exclamation mark, which is known as factorial. Okay. Which means there are 120 ways in which you can have different types of orders for the race to finish. Very good, Aisha. Okay, so this is what we are. Then another example is, see, why I'm explaining is that sometimes, directly it is written. So I'm going to explain how you should think. Okay. And then once you know how to think, then in the exams, you will directly be able to do. There, a classroom has 7 students and 7 desks to fill. So similarly, this is D1, this is D2, this is D3, D4, D5, D6, and D7. Okay. And you have A, B, C, D, E, F, G. Okay. 7 desks, 7 students. Now, now for desk 1, how many people are available? All 7 are available. Okay. So somebody can occupy. So how many students are there? Yes. How many students are there? There are 7 students. Okay. So suppose A has occupied this seat. Okay. So I will cancel A. How many students are left? 1, 2, 3, 4, 5, 6. 6 people are left. 6 desks are left. So for D2, there are 6 students who can, any of the 6 can take. Okay. So suppose D is occupying. So I cancel D. 1, 2, 3, 4, 5. 5 students are available for 5th, for D3. Suppose F has occupied. So I will write F over here. How many people are remaining? 1, 2, 3, 4. So for the 4th desk, 4 people are available. Suppose G is occupying. So I'll cut G and then G. Then for desk 5, 1, 2, 3. 3 people can occupy desk 5. So suppose B is occupying. So I will say B is occupying this desk. So I'll write B. How many people are remaining? C and E, 2 people are remaining. So here I have 2. I say suppose E has occupied this. So E. So last place there is only C left and only 1 desk left. So poor chap C, he will not have a choice. He will have to sit on that chair, whichever is given to him. Okay. So what this means is, so I have written over here, how many ways in which 7 students can be arranged in 7 places is this. 7 into 6 into 5, 4, 3, 2, 1, which is written as 7 factorial. There are 5040 ways you can make 7 students sit in 7 chairs, okay, on 7 desks. So isn't it so exciting that you have so many choices? हम लोग बोलते हैं ना लाइफ में, अरे मेरे पास चॉइस ही नहीं है, मुझे यही करना पड़ रहा है, वही करना पड़ रहा है. आप देखिए, अगर टेबल चेयर पे बैठने के लिए इतने चॉइस है, तो लाइफ में आपको डिसीजंस लेने के लिए कितने सारे चॉइसेस है. ठीक है, तो यू शुड बी हैप्पी एंड ट्राई टू डू इट. नाउ अगेन, coming to the exam point of view, these are the factorials that you must know. Okay, you can always calculate. डरने की बात नहीं, अगर आपको याद नहीं आ रहा है तो there is nothing to worry about, but you must know these. Okay, 3 factorial is 6, 4 factorial is 24. I will write and also show. Just a minute. My water. Okay. Now, how do I write 3 factorial? 3 factorial is, जो भी नंबर है ना उससे शुरू करते हैं. We will always start with this number. So this is 3. Then 3 से नीचे एक नंबर कम, 2 into 1. 3 into 2, 6. 6 into 1, 1, which is equal to 6. What about 4 factorial? 4, 3, 2, and 1. 1 जो है, because it's supposed to be written, but for exam point of view, you don't have to worry. 3 into 2, 12. 12 into 2, 24. Okay. 6, 24, 120. 7 factorial is 5040. 8 factorial is 40320. 9 factorial is 362,880. 10 factorial is 362,880. Okay. If you at least know this, what happens is sometimes you will find this number 362,880 and you will start thinking, मैंने ये number कहाँ देखा है? Then you will suddenly realize, अरे ये तो 9 factorial है. ये स्पेशली स्टैटिस्टिक्स में बहुत लग जाता है आपको. तो दैट इज व्हाई इट्स सो वेरी इंपॉर्टेंट दैट यू अंडरस्टैंड दैट दीज नंबर्स, एंड इट्स वेरी इजी टू लर्न आल्सो, यू नो. एंड दिस शुड अगेन गो टू योर formula notebook that I keep talking about. Yes, very good, Abhinandan. 0 factorial is 1. We will be doing that also. So that is in the special one. So 0 factorial is 1. 1 factorial is also 1. This is a very important thing that you must know. 0 factorial is 1, 1 factorial is 1, 2 factorial is 2. Okay. But most important is 0 factorial is 1, 1 factorial is also 1, 2 factorial is 2. Then after that, 3 onwards, things are changing. Okay. Pushkar, this is, I think, it will be there. If you have attended the earlier LCC things, it is there. This fact and this PDFs are all there, already uploaded. Okay. Okay, Pushkar. Now, coming to multiplication rule and addition rule. First thing can be done in m different ways, and when that thing is done, the second one can be done in n different ways. Then the total number of ways in which both things can be done. It is not some, it is done. Simultaneously is m into n ways. When we read this in the book, you know, we say, "Kare baap re, kya hai?" Or especially if you are from vernacular medium. Okay, Mohit, I will ask, and I'll put it in the break. I will ask and let you know. Okay. But there is a link, there. I think it is there and on the website, BOS website. But see, what this means is, okay, what this means is there are two. Suppose I want to do two things. Okay, I want to do two things. I will do one thing first. When that is over, I will do another thing. Okay, one thing first, and then once that is finished, I will do another thing. Then, when will my job be completed? When I have done both the things. Okay. If I do one thing and leave it, it will not be over. Okay. So I have to do one thing. After that is complete, I will do another thing. And when both of them are done, it is said that I have completed the job. So in how many ways can I do that? So first job, if I can do in m ways, second job, I can do it in n ways. So m into n, which is equal to m into n ways in which you can get the job done. Okay. This is the theory part. I will explain with an example, no doubt. But now you will understand. First thing can be done in m ways. एक काम है, I have one work and it requires two steps. Okay. So step 1 and step 2. Okay. So only when I do both these will the work be done. So first thing, that is S1, can be done in m ways. So S1 can be done in m ways. And when that thing is done, when this is done, okay, I can start with S2. But S2 can be done in n ways. So when will I say that my S1 plus S2 is done? When both S1 and S2 are done, can I say that? It can be done in m different ways. In how many ways can S1 and S2 both be done? It is m into n ways. Okay. I will be taking an example. Don't worry. Okay. So if one goes to school by 5 different buses. So let me see. Okay, this is Rashmi. That is myself. I am at my home. Okay. And I have to go to school. Hmm? Now what happens is, if I go to school by 5 different buses, okay, so I come to the bus stop and I can see B1, B2, B3, B4 and B5. I can take any of these buses because all these buses go to my school. So how many choices do I have? 5 choices. And then come back by 4 different buses. While coming back, I have BB1, BB2, BB3 and BB4. Okay. Now when this is the case, what can happen is I go from home to school. Okay. This is from home to school and then school to home. Home to school, I can take B1. When I take B1, while coming back, I have these 4 choices. So I can take either B1, BB1, BB2, BB3, BB4. So I have how many choices? 4. While starting from here, I can take B1, B2. But if I take B2 also, how many choices do I have? 4 choices for coming back. B3, again 4 choices. B4, again 4 choices. And B5, again 4 choices. So from home to school, how many choices do I have? 5. And while coming back also, how many choices do I have? 4. So if the task is, what is the task? What is the task? Going from home to school and coming back. Okay, and coming back. Home to school and coming back. So home to school and coming back is one task. ऐसा नहीं है ना आप स्कूल में जाके बैठ के वापस ही नहीं घर आ रहे, आप स्कूल में बैठे रहोगे, ऐसा तो होता नहीं है ना, हम स्कूल जाते हैं वापस आते हैं। तो अगर हम स्कूल जाने के लिए मेरे पास 5 बसेस है और आने के लिए 4 बसेस है, मैं उनमें से किसी भी बस में से आ सकती हूँ। तो हाउ मच, व्हाट इज द टास्क? मेरा स्कूल जाना और स्कूल से वापस आना, दिस इज वन टास्क। एंड व्हेन हाउ मच, इन हाउ मेनी वेज आई कैन डू इट? 5 into 4, दैट इज 20 ways टू डू इट। ठीक है, देर आर 20 अलग अलग कॉम्बिनेशन से मैं बस चूज कर सकती हूँ जाने की और आने की। Okay, this is known as the multiplication rule. Okay, when I have a job, first job, what is the first job? Going to school. And once that is completed, that is when I'm in the school, I have done my school timings and I want to come back. That is S2. Okay, so ये मेरा S1 जो अभी बताया था, and this is my S2. दोनों काम एक साथ करने के लिए there are 20 different ways. Okay, so just we'll read through again. First thing can be done in m ways, and when that thing is done, another can be done in n ways, so m into n ways. Okay. Now comes to the addition rule. If one job can be done in m ways and an alternative, this word is the most important word. An alternative job can be done in n ways, then either of the two jobs. This is S1, okay, S2. ये मैं अल्फाबेट्स अलग ले लेती हूँ वरना फिर। Okay, this is T1 and T2, not 22, T2. Means what? There is one work, one job. Okay, there is one work or job. एक ही है। वो जॉब करने के लिए आइदर मैं T1 यूज करती हूँ या T2. So only for that one job I have both options. Okay, I can do it either with the way T1 or T2, but work is one. In the multiplication rule, you had two things that make up your work. Here there is only one work and you can do it either ways. So so then it can be done in this T1 I can do in M1 ways, or this I can do in N ways, M or N ways. Then the job can be done in M plus N ways. Okay, let us take an example. And this is something again most important, ये by heart होना चाहिए, that should be there in your formula notebook. Okay, if you see add, means you must multiply. If you see or, it must mean add. Means I can do the job in either T1 or T2 ways. So in that case, I have to add. If I need to do both S1 and S2, I need to multiply. So again, taking the example of the bus, of going to school. Now, ये मेरी बस की हो गई, लेकिन क्या है वहां पे बस स्टैंड के पास आपको मालूम है ऑटो भी खड़ी रहती है. सो ऑटो, सपोज A1, A2, A3 and A4. What is the task? What is the work? Going to school. Okay, what is the task? Going to school. So now what happens is when I have to go to school, I just have to go from the home to the school. What are the choices I have? I may either go by bus, or by auto. Okay. मैं एक ही टाइम में बस में भी बैठूंगी, ऑटो में भी बैठूंगी, ये तो होता नहीं ना. मैं आइदर बस में बैठूंगी या ऑटो में बैठूंगी. अगर बहुत लेट हो गया है तो मैं ऑटो से चली जाऊंगी, लेकिन मेरा बस का पास है तो मैं बस से भी जा सकती हूँ. सो बस और ऑटो. सो द वर्ड इज और. Then what are the options with bus? I can go by either of these 5 buses. So this is 5. Auto, how many autos are standing in the auto stand? 4 autos. So from home to school, how many ways can I go? I can go by 5 plus 4, which is equal to 9 ways. Okay. I can go from house to school. Okay. Again, I repeating, this is important because this is extremely important when we are doing statistics. So that this concept, once you've understood, it becomes very easy for you over there. Okay. So now let us come to the formula that we use. This is the formula for permutation. Permutation is when order is important. Okay. So you can remember it with the acronym PO. Okay. Permutation order. The number of permutations of n things when R are chosen at a time is given by is this. Okay. So NPR, there is this formula n factorial upon n minus r factorial. Okay. This is also the formula. This when expanded gives you this formula. N into n minus 1 into n minus 2 up to n minus r plus 1. दिखने में बड़ा है, आपको डरने की बात नहीं है. ये जो है ना n इंटू एन माइनस वन इंटू एन माइनस टू मीन्स क्या, आपका जो नंबर है ना उससे एक एक नंबर नीचे नीचे लिखना है. जैसे अगर 5 है, इफ n इज 5, सो 5 4 3 2. Okay, this is important. This term is important. Let me write it in red pen. कभी कभी ना हम भूल जाते हैं, तो इसलिए n माइनस आर प्लस 1 ये वाली टर्म आपको याद रखनी है. बस ये तो सिंपल है, n इंटू एन माइनस वन इंटू एन माइनस टू, बस n माइनस आर प्लस 1 करना आपको याद रखना है. So this is what you should be doing it. N factorial upon n minus r factorial is the way. If I have n things and I want to do r things, then how can I do it? I can arrange r things in out of the n things in how many ways? N factorial upon n minus r factorial. Okay. अगर मेरे पास जैसे जब पासवर्ड बनाते हैं, like when we are making the password, how many alphabets do I have? 26. But 26 alphabets and 26 lowercase and 26 uppercase. So how much will I have? I will have 52 over there, 52 alphabets. Then numbers 0 to 9, so those are 10. Then again, special characters, depending on the website, they will allow you to take maybe five, 6 of you. You can choose between them. So you can see that there are so many things. Alphabets, numbers, special characters, all these things will form the N. Okay, all these things will form the N. Out of that, password कितना होता है? Normally 8 to 15 characters होता है. So those 8 to 15 characters I have to choose from this. Suppose I decide on 10 characters. So out of this whole alphabets, numbers and characters, I have to choose 10. How can I do that? NPR ways. Okay, I have to arrange them in that way. And what is the formula? N factorial upon n minus r factorial, which is equal to n minus 1, n minus 2, till where I am going. This is most important, n minus r plus 1. Okay, so remember this. So the product has exactly r factors. Okay, this is an important theory question. Okay, this is an important. How many factors are there in a permutation? There are exactly r factors. Okay. और इसमें ना ज्यादा सोचने की जरूरत नहीं. You don't have to overthink. You just need to know. Just for MCQ questions, you don't have to explain anything. Whatever is the concept, you have to just know it and then you have to just tick mark. Okay. Okay. Now, why I have written this in red is, please remember, we will always follow BODMAS. Okay. Now, the formula is n factorial upon n minus r factorial. Okay. What is the formula? The formula is n factorial upon n minus r factorial. See, while writing or speaking, I will not say into bracket, but you already know in BODMAS what should be solved first? The bracket. तो बहुत बार ऐसा हो जाता है कि हम वो फैक्टोरियल की साइन है ना, वो आर को ले लेते हैं डिनोमिनेटर में. So you should be very careful. You don't do that. You follow the BODMAS. And as a principle, what you should do is you should always solve the bracket first. Okay. Suppose I have 5p2. So what will I write? Okay. Now this, the number on the top is my n and this number is my r. Okay. So 5 factorial divided by 5 minus 2 factorial. What I would suggest it, at least initially, बाद में तो आप बिल्कुल आराम से कर लेंगे. Solve the denominator first. 5 minus 2. Do that first. How much is this? 3 factorial and 5 factorial. Okay. So first solve this and then you will write it. Okay. So n factorial upon n minus r factorial. 0 factorial, as Aisha or I think Mohit had said, 0 factorial is 1. NPN is n factorial. This is also important for theory. Okay. How much is NPN? Is equal to n factorial. N plus 1 factorial minus n factorial is n minus star n factorial. Okay. That I will explain. Is there somebody? Oh, very nice. Natasha, you've solved it also. So nice. Okay. 5 factorial is 120. See, now I know it because I know that table that I was talking about. 20 upon 3 factorial is 6. So 5 factorial is 120 upon 6, which is equal to 20 is the answer. 20 ways. Okay. Very nice, Natasha. Yes, Aisha has also solved. Yeah, very good. So, NPR is n factorial upon n minus r factorial. 0 factorial is 1. Very good. Then NPN is n factorial. Let us see. NPN. What is the formula? N factorial upon n minus r factorial. N, this is, now this denominator, this n that is written at the bottom is my r over here. So n factorial upon n minus n factorial. This is equal to n factorial divided by n minus n. I will solve the denominator first. N minus n, that is the bracket first. N minus 1 is 0. 0 factorial. I know 0 factorial is 1. So which is equal to n factorial. Okay. So sometimes even if I don't remember this by heart, I can always solve it over there and do it. Okay. Abhinandan, very good. Now let us see this. N plus 1 factorial minus n factorial. Now, what did I tell you? 5 factorial can be written as 5 into 4 into 3 into 2 into 1. Okay. Now, how much will I be able to write n plus 1 factorial? N plus 1 factorial can be written as okay, I have place over here. Let me write it over here. Okay, I have n plus 1 factorial minus n factorial. Okay, this is the sum here. Yes. Now, as I was saying, I can write 5 factorial as 5 into 4 into 3 into 2 into 1. Okay. Similarly, I will be able to write n plus 1 factorial as, जो नंबर है वहां से शुरू करेंगे, n plus 1, उसके बाद उससे एक नंबर कम, so n plus 1 जो नंबर है -1, then n plus 1 -2, है ना, n plus 1 -3. ओके, कहां तक करेंगे ये n minus n plus 1. ओके, ये हम करेंगे कब तक, ऐसे चलता रहेगा, कब तक, नीचे आएगा 3 into 2 into 1, लास्ट में यहां तक आएगा. Now what happens here is I will solve this n plus 1. n plus 1 minus 1 plus 1 minus 1 0 है, this becomes n. n plus 1 minus 2, this will become n minus 1. Then n plus 1 minus 3 becomes n minus 2 up to 3, 2 and 1. Okay. Now, if you can see this portion is nothing but n factorial, है ना? ऊपर किया ना हमने. n factorial is n into n minus 1 into n minus 2 up to this. So, n plus 1 factorial. So, n plus 1 factorial can be written as n plus 1 into n factorial. अब यहां ध्यान रखना है, यहां पे मल्टीप्लीकेशन है. ये n plus 1 into n फैक्टोरियल नहीं है, n plus 1 into n फैक्टोरियल. फैक्टोरियल जो है वो n से चिपका हुआ है. That factorial is with the n. So, I can write n plus 1 factorial as n plus 1 into n factorial. What do I have here? I have this. This can therefore, n plus 1 factorial can be written as n plus 1 into n factorial minus n factorial. What will we take common out? We will take common out n factorial. Okay, common out n factorial. यहाँ first term में क्या है? n plus 1 minus 1. Okay, n plus 1 minus 1. Plus 1 in, minus 1 becomes 0. What will I have? N factorial into n. Okay, so this is the proof. So in case you don't remember, this is the proof. Other than that, you will know this. Okay, so this n plus 1 factorial minus n factorial is n into n factorial. Okay, ये जो factorial है, ये इसके साथ है. This is together and this is separate number. This is simply a number which you are multiplying to the n factorial. Okay, so before we begin anything, I want you to put in the chat box whether or not everybody has understood this. If you have any doubts, just put it in the chat box now. Okay. किसी को भी अभी इसमें से कुछ समझा नहीं है तो अभी बता दीजिए, ताकि फिर सम सॉल्व करते समय हमें कोई दिक्कत नहीं आएगी. Quickly put it in my, yes. Aisha, Inaj, Raj, Suraj. Acha, which, what is your doubt? Okay, Raj, have you been able to solve all the exercises properly? Okay, just see whether you will be able to do that. Okay. Yes, Abhinandan has no doubt. Very good. So see that and then only go to AQB. Okay. Still, I'll see if I should be, I will explain it over here. Okay. Aisha, understood. Very good explanation. Thank you. Okay, Suraj, I will see. I'll explain the table again. Okay. No doubt. Okay. This table you want? Okay. See, NPR is n factorial upon n minus r factorial. Solve the denominator first and then you will then do the factorial. 0 factorial is 1. Okay. Not to choose. What does 0 factorial mean? It means that I will not choose anything. I have n objects. I have to arrange. Like in this case, I want to arrange. For permutation, I want to arrange. In combination, I want to choose. Okay. Now, not arranging anything is also one option. That is why it is 1. How in how many ways can you not choose, not arrange? There is only one way. Okay. And that is why that one is important. कि कुछ नहीं करना भी एक काम है. आप काम करते हो नहीं करते हो, नहीं किया भी एक चॉइस है ना आपके पास। मम्मी ने बोला आपकी रूम साफ कर दो, नहीं करना भी एक काम है ना। आपको मालूम है आपको डांट पड़ने वाली, लेकिन फिर भी आप करते नहीं हो, तो दैट इज ऑल्सो अ चॉइस दैट यू हैव। यू हैव टू चॉइसेस, राइट? आइदर आई क्लीन द रूम और आई डोंट। If I don't clean the room, that is also a choice. That is why that is one way of doing cleaning the house. Not doing the cleaning is also an option. Okay. NPN is n factorial, n plus 1 factorial minus n is this. Okay. हाँ रोहित, वर्ड वाले प्रॉब्लम आ रहा है, मैं समझती हूँ। वही इसीलिए मैंने कंसेप्ट समझ में आ गया कि नहीं वो पूछ रही हूँ। अब बाकी मैं अभी उसके बाद वहीं जा रही हूँ, ठीक है? आप बिल्कुल चिंता ना करें। ओके। यस, आई होप सूरज यू अंडरस्टूड। यस, नाउ लेट अस गो टू दिस। फर्स्ट let us do some warm up with the sums, and then we will go to the word problem. Okay. Raj, I will see. Okay, your problems also I will see. Okay. Now 5p3. Let us see. See, initially you will have to do the whole thing, but then you will 5p3. What is my formula? npr is equal to n factorial upon n minus r factorial. Okay. I have to solve the denominator first. That is, whenever I'm writing the formula, only if I say denominator first, then I will know. 5 factorial. What is my 5? This is my n. What is 3? This is my r. Okay. 5 factorial upon 5 minus 3 factorial. Solving denominator first. 5 factorial upon 5 minus 3 is 2 factorial. How much is 5 factorial? 120. How much is 2 factorial? 2. Answer is 60. जिनको याद नहीं है वो 5 factorial is 5 into 4 into 3 into 2 into 1. Okay. So for exam point of view, don't write into 1. There is no need. But because I'm teaching, I have to teach you the correct way. 5 into 4 is 20. 20 into 3 is 60. ओके, 60 इंटू 2 इज 120। इसीलिए वो वाला टेबल है ना फैक्टोरियल को याद होना चाहिए। ओके। 5p3, 10p2। हाउ मच इज 10p2? 10 फैक्टोरियल अपॉन 10 माइनस 8 फैक्टोरियल। ओके, हाउ मच इज 10 फैक्टोरियल? क्विकली टेल मी, क्विकली हाउ मच इज 10 फैक्टोरियल? याद हो गया सबको? रोहित, कौन सा टेबल बाद में आए हो क्या? फैक्टोरियल का टेबल, ये वाला। ओके, ये टेबल आपको याद होना चाहिए, नंबर एंड द फैक्टोरियल। ओके, दिस यू मस्ट नो। So 10 factorial is 3, 6, 2, 2, 8, 8, 0. Okay, it's easy to even like remember. Where have I gone? Yes, very good, Aisha. Okay, yes. So 10 minus, sorry, 2 factorial. 10 minus 2. 10 minus 2 factorial. This is my n. This is my r. So 10 minus 2 is 8 factorial. Up and 10 factorial. 10 minus 2 is 8. How many is 10 factorial? 3, 6, 2, 2, 8, 8, 0. Okay. How much is 8 factorial? Anybody? How much is 8 factorial? Yes, Parul, I corrected. Yes. नहीं, फाइनल आंसर ठीक है, आपको पहले उसके पहले का आना चाहिए ना। 40320, यस श्री, अभिनंदन श्री। 40320, and then you divide. So directly you have to divide. Okay, so once you know this, let me check. Three six double two double eight double zero divided by 40320. 40320 362 880 368. 362. Okay. 362 8800. Okay, let's see. 362 8800 divided by 40320. Yes. ठीक है ना, सबको आ रहा है ना आंसर 90? Okay, everybody is getting this answer. Yes, Aisha, Sneha, Abhinandan, very good now. So let us do the third one. What is the third one? 11p5. Okay, 11p5. 11p5. What is my n? N is 11. What is my r? R is 5. So how will I write this as? N factorial upon n minus r factorial. Okay, which is equal to 11 factorial upon 11 minus 5 factorial, which is equal to 11 minus 5 is 6 factorial, 11 factorial. Now 11 factorial, I can write it as 11 into 10 factorial upon 6 factorial. Okay, n plus 1 factorial is n plus 1 into n factorial. How much is 10 factorial? I know 11 into 362 8800 upon 6 factorial is how much? 720. So how much is this? Can we find out? 362 8800 divided by 720 is equal to 5040 into 11. 55. This is 11 into 5040. 11 into 5040 is 55440. Very good. Aisha, Abhinandan, Sneha, Natasha. Yes. जितना आप लोग यहाँ पे करेंगे ना, आपको उतना फायदा होगा. Yeah, very nice, very nice. Okay, Abhinandan has even multiplied numerator. Very nice. Aisha also 11 factorial. See? Okay, so this is how it is to be done. Okay. We will do this word example first and then we will take the break. Okay, we will do this first. How many three-lettered words can be formed using the letters of the word? These are two different examples. Okay, so let me first take this. SQARE. Okay. First important step, see whether any letter is repeated. Okay. Because if any letter is repeated, you have to, like they will say no word, no letter can be repeated twice. So that time you will take it as one, and you will be able to solve those sums also. But that is a different thing. Sometimes they may ask you this. Okay, this is important. Second is you must know what your consonants are and what are vowels are. Okay, that also you should know. Any problem that is dealing in letters of words, you must know these two concepts very clearly. Okay? So any letter is repeated, suppose like I use the word calculus. So in that C is repeated, A is repeated, you know. So that time I have to answer the question in a different way. What about consonants and vowels? What is a consonant? Or how many vowels are there? Can anybody tell me? Suraj, I did not take 11 into 10 beta. I took 11 into 10 factorial. बाबा आप वो नीट बात का factorial मत भूलिए. This is 10 factorial. Okay? ये n plus 1 factorial मतलब 11 को कैसे लिख सकते हैं हम? 11 को लिख सकते हैं 10 plus 1, है ना? 11 को लिख सकते हैं. क्यों लिखा है? क्योंकि मुझे 10 फैक्टोरियल मालूम है. ऐसा कोई जरूरी नहीं है, आप 11 फैक्टोरियल पूरा भी कैलकुलेट कर सकते हैं. ठीक है? You can always write 11 factorial as 11 into 10 into 9 into 8 into 7, 6, 5, 4, 3, 2 and 1. Okay, if you are not comfortable, you can write it this way also. You will get the same answer. But because we are using the table up to 10 factorial, I know I can write 11 as 10 plus 1. ओके 11 आई कैन राइट एज 10 plus 1. और ये मेरे पास फॉर्मूला है ना, शॉर्टकट है 11 n+1 फैक्टोरियल. सो मैं 10 प्लस फैक्टोरियल को क्या लिख सकती हूँ? 10 plus 1 इंटू n फैक्टोरियल है, ये पूरा एक साथ है, ये देखो 10 फैक्टोरियल है. 10 फैक्टोरियल आई नो इज 3628800. 10 plus 1 is 11. Okay, I hope you've understood. Yes, Abhinandan, you can do direct cancellation also. Rohit, what have you written? Better. No, no. Aisha, I'm asking how many total vowels are there? Parul, Aisha, I'm asking total vowels. Okay. See. Right. 5. So I know most of us know it, but how many vowels are there? Vowels are 5. Which are there? A, E, I, O, U. How many consonants are there? All other. All other alphabets that is other than A, E, I, O, U. मतलब कौन से B, C, D, F, G, H, J, K, L, M, N, P, Q, R, S, T, V, W, X, Y, Z. जिनको कोई भी दिक्कत है इसका स्क्रीनशॉट निकाल के रख लीजिए. ओके, सो यू कैन सी दैट. Yes, very good. Rohit Parul, there are 21 consonants. There are 5 vowels and 21 consonants. कितने consonants are 21? Now, in this sum, I may not need it. But that is what I need to know. How many three-letter words can be formed? Square, SQARE. So how many letters are there? Let me check. 1, 2, 3, 4, 5, 6. So number of letters is 6. How many? Three-lettered words. So what is this? This is my N. And what is my R? R is 3. Okay, how many three-lettered words? So how many words can be formed is this. Okay, NCR. So this thing. 6P, 3. So this is 6 factorial upon 6 minus 3 factorial, which is equal to 6 factorial. 6 minus 3 is 3, so 3 factorial. This is 720 and this is 3 factorial is 6. Sorry, वापस मैंने 3 लिख दिया. हमें मालूम है वो टेबल यूज करना है. 6 factorial is 720. This is 6 factorial and 3 factorial is 6. So answer is 120. What about hexagon? HEXAGON. How many letters are there? 1, 2, 3, 4, 5, 6, 7. So N is 7. How many lettered word do I want? R is 3. So 7, 7P 3 is equal to 7 factorial upon 7 minus 3 factorial. धीरे धीरे ना आपको ये 7 minus 3 लिखने की जरूरत ही नहीं पड़ेगी. आप डायरेक्टली लिख दोगे 4 factorial. This is equal to 7 factorial upon 4 factorial. How much is 7 factorial? Anybody? 840? Very good. Answer? 7 factorial is 5040 और 840 क्या है? 4 factorial is how much? How much is 4 factorial? 7 factorial is 5040. Very good. Yes, 4 factorial is 24. So 5040 upon 24 is how much? 210. Right? Excellent. Very good. Very good, all of you. Okay. So let us take a 5 minutes short break, and when we come back, we will be going further now, and we will be doing as many word problems as I can. Some I'm going to solve, the others I'm going to explain so that we save time on writing it down. Okay. Everybody with me? Yes. Ashok ji? हाँ, 5 मिनट का ब्रेक ले लेते हैं जल्दी से. थैंक यू. Now, first, second, and third prizes are to be awarded at an engineering fair in which 13 exhibits have been entered. In how many different ways can the prizes be awarded? Okay. So I have the first prize. I have the second prize and third prize. Okay. So how many people are there? 13 exhibitions. Okay. So 13 exhibits are there. So there are 13 people in who can win the prize. So how many are there eligible for the first prize? All 13. Okay. All 13 are eligible for the first prize. Then one of them has got the first prize. The one who has got the first prize will not be eligible for the second prize, right? So out of 13, one has gone, 12 will remain. मैं आपको इंग्लिश में बताया है, अब हिंदी में भी बता देती हूँ कि 13 लोग कंपटीशन में मतलब एग्जीबिशन लगाया है। 13 आपने देखा होगा ना, इंजीनियरिंग के जो स्टूडेंट्स है वो एग्जीबिशन लगाते हैं। तो उसमें देखिए 13 स्टॉल्स हैं, 13 ग्रुप ऑफ स्टूडेंट्स ने है ना अपने प्रोजेक्ट्स लगाए हैं वहां पे एग्जीबिशन में। तो उनमें 13 में से सबको इक्वल चांस है फर्स्ट प्राइज मिलने का, तो वो 13। तो उसमें से एक को मिल गया फर्स्ट प्राइज, तो बचे कितने? 12। तो उन 12 में से सेकंड प्राइज जाएगा। ओके, सो यू हैव टू हैव लाइक आउट वन वन ग्रुप हैज already got the first prize, so remaining there will be 12. Okay, out of that, the one more group has gone. Okay, one group got the first prize, another group got the second prize. So how many will get, how many are eligible for the third prize? 11 of them. So 13 into 12 into 11. Anybody can tell me the answer? 13 into 12 into 11? Abhinandan, how did you get such a big answer? 13 into 12 into 11. Yes. So this is 1716 ways in which 13 groups who are competing for the first, second, and third prize. There are 1716 ways in which I can give the prize. Yes, Rohit, Natasha, very good. Okay. So now, in how many different ways can 5 people stand in a line for a group photograph? Okay. So there are 5 places. 1, 2, 3, 4, 5. How many students can stand over here? 5. Once one student has stood over here, this place can be occupied by one of the 4 people. Then this can be occupied by 3, 2, or 1. Okay. So this is nothing. 5 into 4 into 3 into 1 is 5 factorial. And answer is how much? 120. Okay. So in how many different ways can 5 people stand? अभी आप बोलेंगे यहाँ एनपीआर क्यों नहीं यूज किया? क्योंकि आर कितना है? आप एक तो ऐसा कर सकते हैं, या यू कैन से एन भी 5 है और आर भी 5 है. सो एन इज हाउ मच? एनपीआर. सो एन इज ऑल्सो 5, आर इज ऑल्सो 5. Are you saying that out of 5 people only 3 people will stand in the photo? No, you are saying there are 5 people, all 5 people will stand for the photo. So npn. So this is 5p5, which is npn. npn we know is n factorial. अगर आपने ये वाला अच्छे से कर लिया ना, तो आपको लिखने की भी जरूरत नहीं पड़ती. यहाँ पे देखिए, 5 people, 5 places, npn is 5 factorial. ये वाला फॉर्मूला हम लोग यूज कर रहे हैं. ठीक है, लेकिन वही मैं बता रही हूँ, कोई भी फॉर्मूला, permutation and combination is such a good chapter where if you don't remember any formula, still you will be able to do. See here, what I did. These are 5 people who are standing for a photograph. 5 into 4 into 3 into 1. I am getting the same answer. This is what? NPN, which is equal to 5 factorial. Okay. Very good. Rohit, Abhinandan, Ayesha, Natasha. Okay. Yeah, very nice. In how many different ways can three students be associated with four chartered accountants, assuming that each chartered accountant can take at most one student? As you know, after you clear your exams, foundation, then when you are done with your this intermediate, then you go in for doing your articleship. So what will happen is each chartered accountant has a limit on number of articles he can take under him. This is determined by how much experience he has. Okay, so he has become a chartered accountant. So as you know, I think you all know, and if you don't know, please pay attention. There is an ACA. Once you pass your CA final exam, you become an associate chartered accountant. This you will hold for 5 years. After 5 years, you will become FCA. Okay, fellow chartered accountant. So there, when you are an ACA, there are you can take less number of students under you for articleship, and when you become FCA, it becomes more. Okay, so when that happens, why? Because you now become more experienced, so you can teach more students. So that is why you become an FCA. Okay, so suppose there are four chartered accountants: CA1, CA2, CA3, and CA4. In how many ways can three students, okay, three students associate themselves? CA are four and students are three. Okay, 4p3, 4 factorial, 4 minus 3 factorial, which is equal to 4 factorial upon 1 factorial. 4 factorial is how much? Everybody? Yes, Abhinandan, Rohit. Yes, Rohit, now you have caught up. Okay, now you are able to answer with speed. Yes, this is 24. अगर आपको फिर भी याद नहीं रहता, तो I'll just tell you for this example only. I'll tell you. See, there were four students, three students. So there was suppose S1, S2, S3. S1 goes to CA firm 1 and he says, okay, I will do my articleship under this CA. This is over. Now S2 and S3, two students. Now S2, suppose I go to S2. S2 has option 1, 2, 3. S1 had how many options? He had four options, 1, 2, 3, and 4. But now one CA has gone, like he's already got a student under him. So S2 goes and over here. So he has three options. So S2 has three options. Suppose he goes to CA2. Now what about S3? S3 has how many options? Two. So S3 has two options. Either he can go to CA3 or CA4. Suppose he goes to CA3. So 4 into 3 into 2. 4 into 3 into 2, which is again equal to 24. So either of these way, whichever way it is convenient to you, you can answer. Yes, Rohit. Okay. These are the type of problems I think some of us have a little issue with. If 6 times the number of permutation of n things taken r at a time is equal to 7 times the number of permutation of n minus 1 things taken 3 at a time. ये जो है ना 6 times the number, मतलब टाइम्स आ गया ना वर्ड, टाइम्स माने क्या हो गया? What is the meaning of the word times here? Anybody can tell? What do you mean by times? Into, yes, multiplication. Okay, so here times means into, or you will use multiplication. क्या करना है? हमें मल्टीप्लीकेशन करना है. Okay, 6 times, so 6 into permutation of n things taken 3 at a time. This is together. इसको साथ में पढ़िएगा. Permutation n things अलग अलग नहीं. Permutation of n things taken 3 at a time is the way. किस उसको क्या रिप्रेजेंट होता है? NP3 टेकन 3 एट अ टाइम. 3 क्या हो गया? मेरा R हो गया. N क्या है? मेरा N ही है. परम्यूटेशन ऑफ n थिंग्स टेकन R एट अ टाइम इज इक्वल टू 7 times. So 7 into number of permutations, नंबर से नहीं, ये एक साथ है. Permutation of n minus 1 things taken 3 at a time. यहाँ पे मेरा n कितना है? n minus 1, और 3 क्या है? मेरा r है. n 7 into n minus 1 p3 at a time. Okay? Yes, Garv, very good. Enoch, Rohit, then Enoch, Abhinandan, Garv. Yes. Okay. This is the formula. See, you can do it in the shortcut way also, but if not, you will just write it as it is. 6 factorial into n factorial, इसको लिखना है n factorial upon n minus 3 factorial is equal to 7 into n minus 1 factorial. Now this denominator is very important that you remember. Now नीचे क्या नॉर्मली हम लिखते हैं n minus 3, लेकिन यहाँ n कितना है? n minus 1. So this is n minus 1 minus 3. Okay, factorial. Okay, n minus 1 minus 3. So this is 6 not factorial, sorry. 6 into n, and this is n minus 1. What is the relation between n and n minus 1? n factorial can be written as n into n minus 1 factorial. ये आप ना याद भी कर लीजिए, उसका लॉजिक की कोई जरूरत नहीं है. It is logical, you can derive it, but n factorial can be written as n into n minus 1 factorial. So this can be written as n into n minus 1 factorial upon n minus 3 factorial. Okay, which is equal to 7 into n minus 1 factorial upon n minus 4 factorial. Okay. Yes, Garg, very good. N minus 1 minus 3 in the denominator, which can be written as n minus 4 factorial. Now some n factorial, I can write it in n minus 1 factorial. Okay. And n minus 3 factorial, I will write it as n minus 3 and n minus 1 है ना, तो n minus 3 minus 1 factorial. Okay, which is equal to n minus 3 into n minus 4 factorial. जो नंबर है उससे एक माइनस कर दीजिए, और so n minus 3 था तो वो n minus 4 हो गया. तो इधर मैं n minus 3 फैक्टोरियल को क्या लिखूंगी? n minus 3 into n minus 4. ये फैक्टोरियल है, ये सिर्फ n minus 4 के लिए है. So this is 6 into n minus 1 factorial. In the denominator, instead of n minus 3, I'm going to write n minus into n minus 4 factorial. So n minus 3 into n minus 4 factorial is equal to 7 into n minus 1 factorial upon n minus 4 factorial. हाँ क्रॉस मल्टीप्लाई भी करेंगे. Okay. Now what am I going to cancel? This n minus 1 factorial is here also. It is here also. N minus 4 factorial is here also. Here also. I have cancelled. Okay. So now what is left is on the left hand side 6 into n upon n minus 3 is equal to 7. Okay. And as now he said, now you need to cross multiply. So what you will have 6n is equal to 7 into n minus 3, which is equal to 7n minus 21. 7n minus n. 6n is equal to 7n minus 21. ये 6n है, ये यहाँ से यहाँ आएगा, माइनस साइन हो जाएगी, माइनस 21 यहाँ से वहां जाएगा, प्लस हो जाएगा. तो you have 7n minus 6n is equal to 21. 7n minus 6n is n is equal to 21 will be the answer. Has everybody understood? Yes, very good. Natasha, Garv, Sri. Okay. Rohit, yes. Abhinandan, yes. Everybody's understood? Very nice. Okay, so this is the answer. Let us go to the next thing. So I'm just writing it again. NPN is n into n minus 1 up to 3 to 1. NP0 is 1. NP1 is n. NP n minus 1 is n factorial. NPR is n into n minus 1 PR minus 1. And this is the way. So ये आप ऐसे और भी कर सकते हैं. n into n minus 1 PR minus 1. This is, you can get it for theory also and you can use it also for solving problems. Then coming to circular. Circular means what? Suppose people are sitting around a table. Hotel mein round table hai. People are sitting around it. So, excuse me, I'm very sorry about that. So, you may have circular permutation of two types. A, you may have circular permutation of beads. Okay, जो गले में माला पहनते हैं ना, मोती वाली माला. So a necklace of beads. So that is one example of circular permutation. People sitting around a table is a form of circular permutation. The number of circular permutation of n different things chosen at a time is n minus 1 factorial. But because, for example, for the beads, if I see the necklace from this side or this side, it is going to be the same because the beads are all round. You will not be able to make a difference. So it is n minus 1 factorial upon 2. Now, what is this symbol? I have purposely taken this because you can write like this or you can write like this also. Okay, these are all the symbols for factorial. Okay, so for necklaces, what is the formula? This is n minus 1 factorial upon 2. Okay, see, ये n minus 1 upon 2 नहीं है, n minus 1 factorial निकालिए, उसको upon 2 कीजिए. Okay, number of ways of arranging n people around a round table so that no person has the same two neighbors. ये वाला condition बहुत important है, is this formula. This again I'm saying important for theory. Theory questions. What is the theorem 1? Number of permutation of n distinct things. Distinct माने, what do you mean by distinct? Okay. Rohit, I will see. Okay. And different things. Distinct means what? Distinct means जो अलग से पहचान आ सके. They are different. What is the other word? Simple word, different. Taken at r at a time. When a particular object is not taken, when a particular object is not taken is n minus 1 pr. Okay. Like I have to choose from 3 people, from 10 people. I have to arrange prizes for 3. Okay, but I'm saying, okay, like in a race, there were 10 students who started the race, but then one student got disqualified. Okay, he stepped on the line, he started wrongly. So, what will happen? Even though I started with 10 students, what will happen? One student is out. So, I have to choose the first 3 position. Okay, now, first, second, third prize from the remaining 9. Okay, so that is why when a particular object is not taken as n minus 1 PR. Okay. Number of permutation of R objects out of and when a always included. ये इसमें क्या था? एक तो लेना ही नहीं है. अब इसमें बोल रहे हैं कि एक को तो प्राइस देना ही देना है. सपोज एक को तो देना ही देना है, हमारा फिक्स हो गया, उसको एक को देना है. तो क्या हो जाएगा? n minus 1 p r minus 1. Okay, n minus 1 p r minus 1. Okay, this you also use it while solving the problems, but at least you must know it from the theory point of view, that you must understand. Okay. Now for combination is just grouping. So this is NCR is equal to n factorial upon n minus r factorial into r factorial. Okay. And this is important from theory point of view. And even while solving, NC0 is 1, NCN is 1, NC, N minus R is NCR. These are called as complementary combinations. And N plus 1 CN is equal to NCR plus NCR minus 1. Okay. ये सब आपको मालूम होने चाहिए. It's all given in the textbook. Okay. You can always, study material, you can always refer to that. Okay. Now let me just, okay, I'll take 1, 2 sums and then I'll see whatever your doubts are. I will try and solve as many as possible. Let S be a collection of 8 points on a plane, in a plane with no 3 points on a straight line. Find the number of triangles that have points of vertices. Okay. So how much will this be? 8C3. Okay. Okay. Yes. These are the sums I want to discuss with you for your understand, because I know most of you have problems with the word problems. Just a minute. Compute the sum of 4-digit numbers which can be formed with the 4 digits 1, 3, 5, 7 if each digit is used only once. So what are the digits I have? 1, 3, 5, 7. So if I talk of the numbers that will start with 1, so I can have 1, 3, 5, 7. Okay. Then I can have 1. And in this 5, 3, 5, 7, I can have 3, 7, 5. Okay, if I keep 1 and 3 common, then I can have 1, 3, 5, 7. I can have 1, 3, 7, 5. Then what I can do? I can have 1, 7, 5, 3, 1, 7, 3, 5. Okay. Then I can have 1, 5, 3, 7 and 1, 5, 7, 3. ऐसे करते जाएंगे तो बहुत लग जाता है टाइम. ठीक है, लेकिन ये डुएबल होता है. मतलब आपको जब अंडरस्टैंडिंग के लिए चाहिए तो यू कैन स्टिल डू इट. Now the number of arrangement of 4 different digits taken 4 at a time. See, what is the biggest thing? There are 4 digits and how many digit words you want? You want 4. 4 digit words from 4 digits. So that I know is 4p4. 4p4 I know is n factorial. which is equal to 4 factorial is 24. Okay. So how many numbers are there? There are 24 numbers. So as you can see, this is 6. Starting with 1, there are 6. Starting with 3, there will be 6. Starting with 5, there will be 6. And starting with 7, there will be 6. So 6, 6, 6, and 6. 6 fours are 24. Okay. So you get 24. Now, but what do they want is, see, you must always remember to read the questions. Compute the sum of. They don't want how many numbers are there. If had they asked you that much, there are 24. They want you to find the sum. So each digit will occur 6 times in each position. So you have 6 into 1 plus 3 plus 5 plus 7. Okay. So how much is this? 12 plus 8. 20? No. 4. This is 4. 4, 9. 9 plus 7. 16. 16. 16 6 are 96. Okay. Now there, that means now you have 4-digit numbers. So 1, 2, 3, 4. What is this? This is the units place. What is this? This is the tens place. Means what? Whatever this number is, into 10. What is this? This is hundreds. So into 100. Units is what? Into 1. That's why I did not write. And what is this place? This is 1000. So that is into 1000. Okay. So what do I have? How many this is? This is 96. So this is 96 into 1000 plus 96 into 100 plus 96 into 10 plus 96 into 1. How much is this all equal to? This is equal to 106656. Okay. No, Rohit, you should take it out of your mind. So in how many different ways can a club with? Okay, let me wait here, and because we are running out of time. I think I will also request for one more lecture, but still. Which question had you asked? Let me see. Please remember that you must first do the exercises first. Where is your question, Rohit? Which question were you asking? I'm not able to find. Exercise A, you were saying, na? Can you just post it again? Question that you want? Okay. Girl, please repeat question 10. अच्छा, कौन सा वाला? अभी जो किया हमने? ठीक है, बुक कर दूंगी. Yes, Abhinandan, paper will be MCQ 16, 17, 19, 20, 21 from exercise A. Exercise A. Just a minute. Okay, let me share the screen. Okay, exercise A. C. Okay, this is exercise A. And 16th question in exercise A. Let me see. 10 exam papers are arranged in such a way that the best and the worst papers are will never come together. Okay, so that yeah. Now there are 10 question papers. So whenever you have, they never come together. What you will do, you will find out how will they come together. So you have 10 question papers. Out of them, 8 are normal papers. Okay, normal papers. One is the best paper and one is the worst paper. Okay. So what I do, I have 8 normal and then I put the best and the worst paper together. So 8 normal paper and this I will consider together. Best and worst. So how many total papers are there? 9. Okay, now because I am considering best and worst, I have joined them together. So there are 9 papers, 9 pn, so that is 9 factorial. Okay. Now what happens in that? You will have this best and worst, so that is 2 factorial. Okay, best and worst is 2 factorial. So if I have 10 papers in which the best and the worst are together, this is the way I will form them. But I I don't want that, right? I don't want them to be together. So normally 10 papers I would have found in 10 factorial ways. Now this is the condition that I don't want. So out of this 10 factorial, I want to remove this. Okay, out of the 10 factorial, I want to remove this. Now what is this? 10 factorial, I'll write it over here. 10 factorial minus 9 factorial into 2 factorial. How much is 2 factorial? 2. So it is minus 2 into 9 factorial. Now 10 factorial, as you know, n plus 1 factorial can be written as n plus 1 into n factorial, right? So 10 factorial can be written as 10 into 9 factorial minus 2 into 9 factorial. So this is 10 minus, I take 9 factorial common. Okay, I will take this. I will take 9 factorial common. If I take 9 factorial common, what will remain? Here 10 minus 2. Okay, 10 minus 2 is 8. So I have 8 into 9 factorial because this factorial is with this 9. 8 into 9 factorial. Okay. Now this is 9 into 8. This is 10 factorial and this is 8 into 9 factorial. So C will be the answer. Okay, Abhinandan. Okay. Have you understood, Rohit? This 16th and 17th are similar. Okay. Same thing. N मतलब ये वाला जो है ना ये उसका इसको यूज करके ही हमने ये वाला सॉल्व किया ओके एन articles are arranged in such a way that two particular articles never come together. The number of arrangement of such is given by this n minus 2 into n minus 1 factorial. Okay. Is that okay now, Rohit? 5A, question 19, 20, 21, 22, 23, 14 and 23, Parul. And Sri is saying 19, 20, 21, 22, 20. 14th and 23. 14th is what? Let me see. The number of ways the letters of the word computer can be rearranged is. How many letters are there? 1, 2, 3, 4, 5, 6, 7, 8. Are there any letters which are repeated? No. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 letters. 8 letters है कोई भी रिपीट नहीं हुआ है तो हमें कोई डरने की बात नहीं है letters. Okay. So that is 8 factorial ways, which is, I mean, 8p8. 8 factorial ways. You know 8 factorial is 40320. So A will be the correct answer. Now, what happens here is these are the total number of ways in which you can arrange the letter. But in that you have already have the word computer, which is already there. You want to rearrange them. So this minus 1. So this is 4032. 319. So B will be the correct answer. How many total number of words are there? 40230. But you want to rearrange those. So we don't want computer word to be included. So I will minus 1. So 40319. Yes, Parul. That is why. वही समझाने की कोशिश कर रही हूँ कि टोटल अगर मेरे को वर्ड्स चाहिए तो वो कितने वर्ड्स है वो है 8p8 विच इज 40320. ठीक है लेकिन उनमें उनमें वो ऑलरेडी दिया हुआ वर्ड है ना कंप्यूटर उसको निकालना पड़ेगा बिकॉज वी वांट हाउ मेनी in how many ways can we rearrange the word letters. Okay, so we don't want the word that is already there, so I minus 1. So that is why B will be the answer. Understood, Parul? So this step is very important where I am saying this is 40320 minus 1, that is 40319. Okay. Yes, Rohit, Parul. Aisha, 18th. If well, school teams are participated in a quiz, then the number of ways in which the first, second, third position you can write it as 12p3, which is 12 factorial. 12 minus 3 is 9 factorial. Okay. So this will be equal to 12 into 11 into 10, which is I think 1320. ये मल्टीप्लाई करके देख लीजिएगा. प्लीज मल्टीप्लाई. 19th is similar to the one we did just now with 96. Okay, so same method you have to apply. Yes, 1320. Yes. वही बता रही हूँ. 1920 है ना, जो अभी मैंने लिया था ना आपका, सेम सेम है, सेम लॉजिक है. यू जस्ट हैव टू लाइक add them up and multiply it and then you will get. Okay, so here same thing, you have the numbers. What is the addition? 8 plus 6, 14, 14 plus 6, 20, 20 into 6, 120, 120 into this thing. Okay. Aisha, in the question, I subtracted one because the word computer was already given to me in the question. And they did not ask in how many ways, how many words are formed. Okay. What they're saying, in how many ways will you rearrange? How many words are there? When I have 8 letters, when I have 8 letters, I can form how many? 30, what was that? 40320. Okay. But they are asking in how many ways will I rearrange? Okay. वो words का difference है. How many ways will I rearrange? There will be -1 because the word computer is already given to you. That I cannot use because that is not rearrangement. That is already given. Okay. This 1920th अभी जैसे किया था ना, वही वैसा ही है. What is the answer for 19th of exercise 5A? Just let me know. Okay, just let me know that answer. 19th. So, see, this is the same question, 4 digit. Only the digits are 4. Okay, let me take another color. Only the digits are 2, 4, 6, 8. What is the addition? 6 plus 6, 12. 12 plus 8, 20. So, what will you have? This is 24, same. 24. Okay. Now there are 4. So 6 times each number will be repeated. So 6. What is the total? 20. Okay. 6, 4. This is 20. So 6 into 20 is 120. Now again 1, 2, 3, 4. This is my unit place, 10 place, hundreds place, thousands place. Okay. So what will I have? I will have, I'm writing it over here because there is no place. Unit place के लिए 120 plus tens के लिए 120 into 10 plus 120 into 100 plus 120 into 1000. इसको ऐड करके बताएंगे कोई कितना आ रहा है? Somebody will be able to tell me. This is 120 into 1000 120 into 1000 120 into 1000 plus 120 into 100 plus 120 into 10 plus 120. 133 13320. Yes, thank you everybody for the answer. So 13320. ठीक है? I will explain once again. How many numbers are there? 4 digits are given. Add those digits up. Okay. How many digits word do you want to form? 4-digit number. 4 digits दिए है, 4-digit number है. Okay. So what will you have? That is each digit is going to be repeated 6 times. Okay. यहाँ पे करके दिखाया मैंने, एक के लिए करके दिखाया इस एग्जाम्पल में. ऐसे आप किसी भी एग्जाम्पल के लिए कर सकते हो. So it is going to be repeated 6 times. So 6 into whatever the addition of those numbers is, 6 into that. Okay. And for each of the place, unit place, tens place, hundreds place, and thousands place, you are going to multiply. Okay. So now everybody is understood. Yes, please put in the chat box whether or not you've understood. Yeah. हाँ कर दीजिए कर दीजिए. Okay, see, this is the okay. We have done this. Then okay. Let me see who had asked this AC AQB question. I think. Who had asked me this AQB question? Okay. Whoever asked me. See, permutation when each thing may be repeated once, twice, up to r times. Okay. Once, twice, or up to r times in any arrangement is given by n raised to r. Okay. When anything is repeated anytime, so it is n raised to r. So there are n different things and any of these may be chosen as the first thing. Then there are n ways of choosing the first thing, है ना? मेरे पास n चीजें हैं, 5 चीजें हैं, उसमें से मुझे एक लेना है, तो मेरे पास पूरे 5 हैं अवेलेबल. सो दैट इज द केस. देन उसको उसको बाद फिर वापस मेरे पास उतने ही हैं. सो उस समय देर इज दिस क्वेश्चन इन AQB अबाउट पोस्ट बॉक्स एंड लेटर्स. I think 66 or something, or letters. There are 4 post boxes and 9 letters. Okay. There are 4 post boxes and 9 letters. So in that case, how many post boxes are there? 4. and raised to 9. Because here there are 4 post boxes and the 9 letters can be put in any of the 4 letter boxes. So when each thing may be repeated once, twice, up to r times in any arrangement. Okay? So in this case, this is the case. This will be the answer, right? Any other question? I think everybody has understood now. Yes, understood. Yes. Circular permanent. Yes, Abhinandan. Yeah. See, this is better way. Like 4 people are sitting. Okay, 4 people are sitting. So what happens is A, B, C, D. Who are the neighbors of A here? Neighbors of A are neighbors of A are B and D. Neighbors of A are B and D. Now what happens in this arrangement? Neighbor of A is again A and D. B and D, sorry. Neighbors of A are B and D. Neighbors of here also B and D. Then here also it is, this is by mistake. Okay. Okay. Here what is happening? It is B and D. But here what is happening? Here A, suppose this is B. C, D, A, B. This is A and this is B. There is, I think, printing mistake. A, B. Okay. C, D, A, B. Here again B and D. So what this means is I am just going in this anti-clockwise direction. A was here, A became here, then देखा आपने A यहाँ पे है, बाद में A यहाँ पे है, then यहाँ पे है और फिर यहाँ पे है. तो मेरा anti-clockwise movement चल रहा है. So if we place A, B, C, D in that order, we get this. These are all as one. Okay. ये जो अरेंजमेंट है वो एक जैसी बनती जाती है. So that means what I do here. So number of ways of arranging n people in the round around a table so that no person has the same neighbors is n minus 1 upon factorial upon 2. This is n minus 1 factorial upon 2. Similarly for beads also. Okay. Like you have A, B, C, D. Then, so what happens? I have A, B, C, and D. This is what the drawing is, A, B, C, D. So this is in this direction, or I can have A, B, C, D. So here this was anti-clockwise, this is clockwise. But here in both these, I have the same neighbors. A has the same neighbors, A and B, B and D. But what will happen if I have the arrangement I have is A, C, D, B. Then I will have a different arrangement. So for one arrangement, you can see there is a mirroring. You can see कि एक बार मैं क्लॉकवाइज भी वही चीज लिख सकती हूँ या एंटी क्लॉकवाइज, उसमें मेरे नेबर चेंज नहीं होते हैं. हाँ, वो दोनों टाइम मेरे नेबर सेम रहती है. मैं इस तरह से बैठूं या उस टेबल उधर से बैठूं. Okay, incidentally I'm sitting around a round table itself. Okay, so those two are as good as 1. That is why you have n minus 1 factorial divided by 2. See, number of circular permutation of n different things chosen at a time is n minus 1 factorial. Okay. This is one important. The second is when I don't have the same neighbors. Okay. यहाँ आपने देखा इन दोनों को मिला के एक ही अरेंजमेंट बन रही है मेरी. Okay. I am able to form only one arrangement. So that is why we say no person has the same two neighbors. Same two neighbors. No person has the same two neighbors is given by n minus 1 factorial upon 2. Because when I have n people and there is no restriction, मतलब कोई कंडीशन नहीं डाली है, रिस्ट्रिक्शन माने कंडीशन, then I can have circular arrangement in n minus 1 factorial. But when I don't want to have the same two neighbors is because one thing can be viewed as clockwise or anti-clockwise. They will form 1. So that is why this is divided by 2. Okay. Rohit, you please inform also. I will also inform the BOS that we will need one more lecture for combinations also. Okay. Let us end today's session. Up till now, I hope everybody has understood everything. Just put it in the chat box and then we can stop for the day. Okay. And then we can take an extra lecture. I will inform and then we can have it sometime later. Okay. This schedule we will complete and then we'll go back. Okay. Yes. Yes, very good. Thank you all. Yes, thank you all for having a patient time. अरे ऐशा saying आज time pass हो गया पता ही नहीं चला. Thank you for the beautiful lecture. Garv is saying yes. Abhinandan is saying thank you for your wonderful explanation. Thank you so much. Okay, have a great day ahead. Ashok ji, can we stop? Yes, thank you so much. Thank you.